Welcome, everybody. Thanks for joining us today for another VECAN Winter Webinar. I'm Dan Fingus. I'm the Climate Action Coordinator for Vermont Natural Resources Council, and welcome to Heat Pumps 101 webinar. This is the second in our series of winter webinars that provide education tools and support to local energy leaders. I hope you can join us at future webinars, including a webinar featuring the Vermont Energy Education Program's community workshops on February 14th, a webinar from window dressers on February 28th, and a How to Develop a Thermal Energy Network webinar on March 13th. I'll throw links for all of the registrations of those webinars in the chat. Want to quickly turn to today's webinar. We're lucky to have 4 knowledgeable and experienced presenters from Efficiency Vermont, and I want to introduce you to our facilitator for the webinar, Becca Custer, Community Engagement Manager at Efficiency Vermont. Take it away, Becca.
Thanks, Dan, and thanks so much for VECAN for hosting us today. As Dan said, I'm really just the MC for today, so I can turn it quickly over to the presenters. But as Dan said, I'm the Community Engagement Manager at Efficiency Vermont, so I'm working with communities and town energy committees and other partners, helping folks, understand our programs and how to access them, and then bringing feedback from all of you to how we can make our programs better serve Vermonters. So I'm going to turn it over to Nate quickly, but just an overview of what we're talking about today. Obviously, heat pumps, which is a really hot topic. And our goal for today's webinar is really just to equip you with the information that you need as town energy committees to engage with this topic in your communities and share this information with your communities. So really quickly, logistics, we are recording this webinar and we're going to also share the slides afterwards. So don't feel like you have to take a ton of notes. There's a lot of content on these slides. So Nate Ganesh is an engineering consultant at Efficiency Vermont. So he's going to take it away, kind of talking about the technology, how heat pumps work, the different types of heat pumps, as well as the funding and financing options. Then we're going to have some time for Q&A. If you do have questions that come in that are related to the kind of slides, we'll try to maybe answer them during the presentation, but we'll leave some time at the end for questions. And then I'm going to turn it over to Matthew Smith, who is our PR manager, who's going to talk a little bit more about kind of the strategies you can employ to share this information with your communities, as well as some relevant resources that you can access. So I think that's it for me, and I'm going to turn it. Oh wait, I actually should. Never mind. I'm going to talk a little bit about who Efficiency Vermont is, and then I'll turn it over to Nate. Just as a reminder, folks are not really familiar with Efficiency Vermont. We are a statewide energy efficiency utility, which means that we help reduce the cost of energy for all Vermonters. We do this in a lot of ways, including offering rebates and incentives on efficient products, education, like today's webinar, as well as technical advice, and really help folks understand and make better use of energy and reduce greenhouse gases. And now I will turn it over to Nate to kick us off and talk about heat pumps.
Awesome. Thanks, Becca. And thank you, everybody, for joining us. I'm really excited to give this webinar to all of you and address heat pumps because, as Becca said, super popular topic to address right now. I know for this audience, you guys want to be able to bring really relevant and accurate information to your communities. So we're hoping to cover information that will be really useful for you and stuff that you'll be able to bring out to all of Vermont to help us move in the direction of more and more heat pumps throughout the state. So kind of getting right into it, I just wanted to talk about some of sort of the signposts here, right? What are we going to talk about today? And what types of things we want you to know here at Efficiency Vermont. If you're communicating things to your audiences and your communities, I am going to talk pretty quickly about heating system fundamentals. We won't spend a ton of time there. We'll talk about what a heat pump is and how it works. I think that is a really interesting conversation that a lot of people want to have or are having currently. And I'm not going to get way into the weeds on sort of the principles of refrigeration, but we'll do a high overview so that you can sort of communicate that back to your communities. We're going to spend a lot of time on the types of heat pumps. And what is suitable for your home. I maybe will use the phrase your home a lot. That's kind of how I pitched this presentation. But I hope that information is useful when you're talking to your community members, thinking about their homes. They come to you and say, hey, this is what I have. And you can say, okay, great. I have some resources for you there. And then we'll end a little bit with just some additional resources, things that we want you to be able to sort of talking points and conversation starters that we want you to have. I think it's really helpful as well to address with every house, that each house is unique, each homeowner is unique, or each resident is unique. And so it's helpful to sort of set the stage when thinking about large investments in your HVAC equipment, any changes to the home that a homeowner might make. These questions here. So I think I basically bring these questions anytime I'm having a conversation with a customer at Efficiency Vermont. Some of you maybe have called in, done tech assists or virtual home energy visits. These are the types of questions that I'm always thinking about when I have those conversations. So these are, what are your goals? There are different reasons that a person might come to heat pumps. They might want to decarbonize their home. They might want to save money on their fuel bills. There's a wide range of reasons why someone might turn to heat pumps. So thinking about goals is really important. What are your comfort needs? What's the house currently like? Those are both really relevant in terms of thinking about what kind of system will work for a particular home. What's your distribution system? That's getting a little more into the weeds on the technical side, but that's going to make a big impact on, again, what kind of system might be right for you going forward. How much weatherization has been done, if any? What's the age of the home? All of that kind of factors into sizing equipment, what type of equipment you may need. And lastly, what's the budget, right? So budget makes a huge impact on what kind of projects you might be able to undertake, or also the timeline for projects. Do you start with one thing this year and move to something the next year, or are you trying to do things all at once? That's going to be impacted by your budget. Definitely. So I again like to highlight these 6 questions because they're going to be relevant to any heat pump conversation. I guess if you're writing anything down, I know Becca said probably don't need to be taking a bunch of notes, but if you're writing anything down, I think this is a good place to start. I want to quickly talk about fuel-fired heating systems. I mentioned that we would do a little bit of heating system fundamentals. The most common way that we heat our homes historically has been by burning fuel, right? So this can be a variety of different fuel types. We burn either oil, or gas, or propane, or wood to heat up some thing that we distribute around our homes, right? So that's either air or water, typically. And then we distribute that around our homes to heat our homes. Obviously, fuel-fired heating systems don't provide any cooling. They can be, as we've seen a lot recently, subject to volatile fuel pricing. So that's really one of the characteristics that we see when people are thinking about the cons of a traditional fuel-fired heating system. And there are obviously carbon emissions and air pollutants related to combustion as well, as most of the folks on this call are going to be aware of. I just want to reiterate that top bullet point because it's going to be relevant throughout this conversation, that fuel-fired heating systems distribute heat throughout the house at quite high temperatures, whether that's through air, through water, or through just being a point source emitter like a wood stove. So I guess another way of putting it is thinking about furnaces distribute hot air throughout the house. Boilers are going to distribute hot water throughout the house. Both of those are going to be distributed heating systems. And then wood stoves or space heaters are going to be point source emitters. They're going to be burning fuel in a particular place to provide heat to that place. Wood stoves, really. Okay, so what about heat pumps? How are they different? How are they better? Are they worse in any ways? What do we need to know about heat pumps if we're going to be pitching these to our communities? Let's get right into it. So just to quickly address some heat pump characteristics, heat pumps run on electricity, so you're not burning fuel. That's a major difference. I think a lot of us are aware of that. Heat pumps can provide cooling. There's kind of a debate in the energy efficiency space about the name heat pumps because it can throw people off. They don't realize that they can get air conditioning as well as heating from this equipment. And they are much more efficient than traditional electric resistance heating, right? I think for a long time, people have been opposed to the idea of electric heating because it can be so expensive, but electric resistance heating is considerably less efficient based on sort of the principles of how the two different systems work. So again, I'm not going to spend a ton of time on this, but let's get into how heat pumps actually work. This is just a little diagram here. If you have specific questions about refrigeration systems and some of the technical information around heat pumps, you're definitely welcome to reach out to Efficiency Vermont, have a conversation with somebody in the engineering department, might be myself, And we can get into some of the nitty gritty. For now, I'm just going to kind of go through this at a high level. This diagram I'm displaying here is actually of an air conditioning system, right? So you can see the the cold is on the inside of the house, right? So you're trying to cool the inside of the house. But it's helpful to start with air conditioning systems because we're so familiar with those. Essentially, what you're trying to do is push a cool liquid through your home so that cool liquid absorbs heat. You can see the lighter blue coming back out of the house. It's one of the top right of this diagram. And that's because you're withdrawing heat from the home and rejecting it back to the outside. That's this hot side over here on the left. And remember, you can do this even on a really hot day. So the way heat pumps work is they allow for a temperature delta through the use of refrigerants and phase change. Again, I'm not going to get super into the weeds here, but through those two sort of principles of chemistry, we're able to move heat from one place to another. So we're used to this with our refrigerators, right? They're moving heat from inside the fridge to out of the fridge. That's why sometimes old refrigerators feel kind of warm. And air conditioning units, which are moving heat from inside your house to outside of your house. Heat pumps just work in reverse, right? So they're able to push heat into your house by drawing it from outside. I mentioned earlier that these are a lot more efficient than traditional electric resistance systems. And that's because they're not generating heat. You are always bound by the laws of physics when you're generating heat through combustion or electric resistance. But with refrigeration, you're moving heat, not creating it, which allows it to be considerably more efficient. So that's kind of an important difference between how we traditionally have heated our homes that I think is not often talked about. So if you're working with a constituent or community member who is really interested in how these actually work, I think that's a really good way of pitching it, talking about how they're moving heat, not creating it. That's why they can be so efficient. I include here a little diagram that includes some of the outdoor units, just so you guys are sort of thinking about what this actually looks like when you see heat pumps. If you have a heat pump, it might be a fan coil on the outside of the unit. And it might be some kind of underground set of wells. We'll talk about different types of heat pumps here in a second, but essentially there's some device outside that is able to extract and reject heat to the outdoor environment. And then there's some kind of device inside the house that allows you to distribute heat around. So over on the right, you see a variety of different types of distribution that you can use. And again, we'll get into those with some photos and talk about some specifics. I do want to highlight something I mentioned earlier is that traditional fuel-fired heating systems have really high temperature distribution. So for example, an old school boiler might distribute water around your house that's 180 or 200 degrees. Boilers are sort of easy to think about because we can generally look at the set point temperature. Furnaces can fluctuate a little bit, but with a boiler, we can see exactly what temperature that water is that's going to be moving around your house. With heat pumps, we don't get quite as dramatic of a lift. And so you might be moving lower temperature air or water throughout the house. And that's going to have some implications about regarding what type of heat pump works well in each situation. That's something that people kind of can glom onto and pay a lot of attention to is, well, wait a second, is it getting the same heat that I'm used to? And there are a lot of pros to heat pumps. I think this audience knows a lot of those, but those can really outweigh some of the cons of the lower temperature of distribution that you're getting from a heat pump. But you have to design the system well, you have to size the system well. So we'll talk a little bit about what that actually means. Again, if you have any sort of specific technical questions about design, we're happy to have individual conversations through our customer support network. Kind of doubling down on this, heat pumps do work. I suspect that all of us here have either heard or read or seen some content out there that talks about heat pumps struggling to work when it's below zero or really cold outside. And I just really want to emphasize that heat pumps do work. Heat pump manufacturers continue to improve on the capacity of heat pumps and their ability to fluctuate with the temperature outside. It's important to remember that these systems need good design and good sizing. And there's also an element for existing homes where it's a really good idea, and in fact, essential in most cases, to also improve the thermal envelope of the home, or the insulation and air sealing in the home. So we can talk a little bit about that as we go along, but I just really want to reemphasize this point that heat pumps do work as long as the system's well designed and your home is sort of set up for it. Some of the stories you read online, I follow a lot of industry news, and you read some horror stories, and when you dig into the details, you see mistakes that were made. And when people make smart decisions, by and large, we get really positive feedback on heat pumps working at really cold temperatures, even up here in Vermont. Okay, so we know they work, but which one's right for you? Which one's right for your community members? I really want to spend a lot of time on the next section talking about the types of heat pumps that exist and where they work well, right? So which one works best in which situation. That's going to be the bulk of this presentation. I hope you guys find that helpful. And going forward in conversations, you'll have some resources for saying, oh, you're describing this about your home. I think you should consider this type of heat pump. And something we're going to talk about is that ductless heat pumps are going to work really well for a lot of people. I want to break down all the different technology types, but just to sort of set that stage early, ductless heat pumps are going to be very effective for a lot of people in a lot of situations. And yeah, let's get into that. Let's talk about ductless heat pumps. I include this photo here. It's a nice, clear demonstration of what this looks like in your home, right? So in case you haven't seen them before, a lot of us have seen them. Next time you go to a coffee shop, look up on the wall, they probably have one. This is what that indoor head looks like. And I will, yeah, I guess let's get into it here. So ductless heat pumps go by a lot of different names. So it's helpful to sort of be informed. People will use a lot of different terms to refer to these. A lot of people will just call them mini splits. The mini split is referring to the fact that the refrigeration system is split, right? There's an outdoor unit that in that diagram I showed earlier that's gathering heat from outside, and then there's an indoor unit that's distributing that heat back in the house. And there's refrigerant lines that connect the two, right? So when people talk about split systems, that's what they're referring to. People will often just use the term heat pumps when they're thinking about ductless heat pumps because they're so common. They might use one-to-one. People might talk about multi-split or multi-zone heat pumps. Often these are still going to be ductless heat pumps. They're just going to have multiple indoor units per outdoor unit. I'll talk a little bit more about that. Each indoor head delivers heat into a single space. So these behave a lot more like a wood stove or a space heater. They're point source emitters, to use kind of the jargon. And I have included 3 photos here on the right, so you can see the different layouts. Most of us are familiar with the one on the top. This is the classic wall-mounted unit, but there are also ceiling cassette units. Those have some technical limitations, but can also work really well for people. So I want to point that out. And then there's floor-mounted units as well. So depending on your situation, one of these may work better for you. So I like to call these out because people don't often know that there's more than just the traditional wall-mounted setup. Because these are point source emitters, typically more than one is going to be required to heat an entire home. Sometimes really small footprint homes, we see a single unit being able to heat the whole thing. But in a lot of cases, especially if it's an existing home that doesn't have a perfect thermal shell, you're going to need a couple to heat the home. Some characteristics of a ductless heat pump, and this is a big reason why, as I said earlier, these are going to be the most effective for the vast majority of customers. They're typically the least expensive option. They're fast to deploy, fast to install. They are super versatile in a variety of different homes. You can put them pretty much anywhere as long as you have consideration of the thermal shell. And also, I'll note here, because it's worth saying, I don't think I have a slide on this, but you know, some installers will tell you that you need one in every single room. That's not really true. This gets back to the conversation of what your home is like, what your layout might be like. If someone specs one in a tiny little bathroom all by itself, that may not really be appropriate. Often that's going to be oversized. Again, if you want to get into those details, feel free to reach out to Efficiency Vermont directly. But ultimately, they're going to be versatile in a wide variety of homes. And one of the things that makes these so helpful is that they're useful for partial fuel switching, right? So if you have a fossil fuel system that you are pretty comfortable with, but you're just concerned that oil prices or propane prices are too high, you can switch over to a heat pump for a large portion of your heating, but not all of it, right? So a lot of people have questions about fossil fuel systems for supplemental heating, providing some heat. You don't have a perfect thermal shell on those days when it's below zero. Again, that's not because the heat pump isn't working. It's just because the capacity starts to go down a little bit. So partial fuel switching can be really effective. You can run just the heat pumps in the shoulder seasons and our colder falls and spring days, and then do a split between what you already have and one or two ductless heat pumps in your home. Some other notes here. As I've mentioned, for a complete fuel switch, your home likely needs to be weatherized, right? So if you don't have a really locked down, super solid thermal shell, it can be difficult to use ductless heat pumps to do all of your heating and not end up with a couple of cold spots around the edges. So I just want to call that out. For people who are trying to do a complete fuel switch, a different option may be better. We'll get to those in a second. Or you may need to just really weatherize your house. There's often a requirement for some tolerance of different temperatures throughout the house, right? Maybe you have a little laundry room that's behind a corner and it might not get up to the same temperature as the room where that heat pump is. Again, this is a point source emitter, just like a wood stove. Think about how that wood stove feels when you go into the back bathroom of your house. It might be a couple degrees cooler. Improving the thermal shell of the building is going to help bring that down. But if you, again, thinking back to that original slide I put up with goals and comfort needs, if you really don't like temperature variation, maybe these aren't going to be the right pieces of equipment for you. And I think this feedback comes up fairly often, so I'll call it out that they're visibly prominent, right? I showed you the ones that we typically see are those wall-mounted units. So people do sometimes say, hey, I don't really like the aesthetics of these. Where do these systems work well? These systems pair well with a weatherization project. I'm kind of reiterating that point a lot, and I think it's worth covering. If you are considering trying to really shore up your house, a combo weatherization project and a couple of ductless heat pumps for partial fuel switching is really an awesome opportunity. Homes with simple layouts or open floor plans, maybe not too many little bedrooms. We don't actually know that much about this house on the right, but it's not huge. So that's why I chose this photo. And homes with some kind of existing system that doesn't have problems, right? If your boiler is about to fail, you may have to have a more serious conversation about, okay, what am I going to put in to replace that? But if you have a central zone system that's working effectively, you can start cutting into those expensive fuel bills by using one or two ductless heat pumps. So that's another place these work really well. And then I'll add that they work great for heating or cooling a particular room. Do you need air conditioning in your main bedroom of the house and you're tired of using your little window mounted or rolly AC unit? This is a really good opportunity to cut down on the heating costs and add some cooling. So that's really worth accentuating. Moving over to ducted heat pumps. These are, I'm going to kind of move up the scale in terms of complexity, design, and also cost as I go along. So you'll kind of see the ones I'm going to talk about as we go. So ducted heat pumps are going to be a little more complicated, a little bigger, a little more expensive, but you're going to get distributed heat throughout the house. So that's something that is thinking about comfort needs, thinking about what you want in your home, thinking about what your home is already like. Ducted heat pumps may be the right option for you. So let me tell you a little bit about the characteristics, and then hopefully that information will help you decide, hey, this is the right fit for me. I include a photo here of an outdoor ducted heat pump unit. These are going to be slightly bigger than the outdoor units that you see on a ductless unit, just because they're going to be sized for more of the home, right? Typically, these are going to be sized for several rooms, if not the entire house. So that may be a larger unit. I'm actually going to toggle back a slide and just say, as you can see, this kind of looks like a traditional AC outdoor unit. This is going to be bigger, have more capacity because it's feeding the entire house. In the same way that we talked about cassette, ceiling mounted ductless units or floor mounted ductless units, I want to talk about the fact that there are different types of ducted heat pumps. That's not something that everybody knows. So on the right, that's a photo of a central ducted heat pump. So that behaves a lot like a furnace, right? A lot like if you already have a furnace, you know what the experience is going to be like. You have a single air handler with your refrigerant lines coming from outside, and then that heat gets distributed throughout the entire house. And that's heating and cooling all in the same system. And then there are also compact ducted systems. So I want to highlight those because people may not know about those. Those can work really well. I'll talk about sort of specific examples here in a couple slides, but those can work really well if you're trying to get to a couple of small rooms. You do 1 or 2 short duct runs off of these. They're hidden away. That's kind of why we don't know about them, because if they are in a house, they're often tucked in into the drywall or whatever the interior finish is, but they can be a good way to use a heat pump to get to a couple of small rooms. Again, getting into some of the characteristics here, kind of following the same framework I followed with the ductless heat pumps. You sometimes can take advantage of existing ductwork. So recall my earlier note about the change in distribution temperature for heat pumps versus furnaces. It's going to be different, and often furnace ductwork is sized for that really high heat. Furnaces, they come on, they run really hard, burn a lot of fuel for 45 seconds, let's say, and then they turn off again, right? And they heat up the house, and that's what we're used to. So we don't complain about the sort of drift and temperature variation that we typically get with furnaces. I will say a lot of people who move to heat pumps start to say, oh, wow, it's really nice that my house doesn't fluctuate every 5 minutes or every 15 minutes. They say it's nice that it stays a consistent temperature all the time. However, that consistent output of temperature is usually a lower temperature. So it's worth having a conversation with the contractor. Can I take advantage of my existing ductwork? Often the answer is no, but if you can, a ducted heat pump is a really good solution. One note is that if you already have a system that has central AC, that's probably sized appropriately. I won't say for sure, but that's probably sized appropriately. So that's something to keep in mind. You can have inline air filters. Air quality is a major concern. And these can also be, as I mentioned earlier, helpful for reaching smaller rooms, right? If you think about it, instead of having a single ductless unit in a small room where you don't really need it, in this case, you can have a duct running into that small room. It's great for little bathrooms, great for little bedrooms. So spreading out that distribution is really the hallmark of the ducted heat pump. I'll note that they're typically more expensive than ductless heat pumps. And in many cases, as I was mentioning, the existing ducts may need to be altered or replaced. That's not always going to be the case. If you take advantage of your ductwork, this is kind of a no-brainer choice. If you can't take advantage of your existing ductwork, then this may not be the best solution for you. So that's a conversation to have with your contractor if you already have a ducted system in your home, a furnace. And I'll note, of course, that these are not suitable for homes that can't have ducts, right? For whatever reason, the construction style, there are a variety of different reasons. If you have questions about that, definitely you're welcome to reach directly out to our engineering department. So where do these work well, right? I've given you some of the characteristics. I'll note that homes with unfinished basements that are, normal walking height, full height, unfinished basements are a really good opportunity for a ducted heat pump. I don't know that this house on the right in the screen of this MacBook over here has an unfinished basement, but it's a single story ranch, right? So if it does, you can run, I think of it as the upside down octopus, right? You can put that air handler in the basement and run a duct to every single room. Now you have a really efficient system that was easy distribution. You didn't have to rip out drywall. You didn't have to change any of your interior finishes. So even if you didn't already have a ducted system, or even if you did and it wasn't quite right for a ducted heat pump, having an unfinished basement on a single story house is really, you have a great opportunity for a ducted heat pump. This also pair well with more robust interior renovation. Say you need to run ductwork up to a second story. Well, if you're ripping out a room or putting in an addition or changing the kitchen, something like that, now you have access to the wall studs. Now you have access to changing the ductwork or whatever the distribution is in the house. So obviously that's a conversation to have with a trained contractor who knows about distribution systems and sizing, but that's something that works really well. And these also can reach a bunch of small rooms, right? That's the thing you're getting from ductwork. So more complicated design tend to be more expensive and larger, but you get a better distribution of heat throughout the house and cooling as well. So that's worth noting. Again, I'm working on these my way up in the scale of complexity and cost. As you'll see, as we kind of jump up another tier here on the next slide, So keep in mind that those ductless heat pumps for your community members are often going to be the most versatile and most cost effective. But in some situations, these ducted heat pumps work super well. So like I said, kind of jumping up the scale here, we're going to jump to air to water heat pumps. So these systems can be really nice for people. If you like radiant heating, this is a great choice for you, as we'll talk about here shortly. I just want to call out this photo before I move on to the next slide. You can see there's two fans here. This is a Space Pack. This is a well-known air to water heat pump brand. This is a big outdoor unit, right? Bigger than the ones we've seen so far. And that makes sense because these systems are often sized appropriately. Just talking about air to water heat pumps. So these are whole house systems, right? This is not something that you're going to put in for a partial fuel switch. I think it makes sense if you're considering an air to water heat pump, you're kind of going whole hog here. As you can see on the bottom left, that's a radiant slab. You're changing your distribution here if you're putting in an air to water heat pump. Or maybe you already have a radiant slab. Actually, I should start by saying that. If you have a radiant slab, you're a great fit for air to water heat pumps. So again, radiant heating, these are all kind of photos of radiant heating. So I hope this gives some indication as to the level of complexity. On the bottom right here, you can see that there's a tank involved. There's the heat pump unit itself. There's pipes and pumps and all these different things. So this is going to go up in complexity and cost, but with that radiant heating, you're going to be really comfortable throughout the entire house. I'll note that, as I said earlier, this is lower temperature distribution, right? So where a boiler might run 160 or 180 or 200 degree water throughout your house, an air to water heat pump is probably going to work more efficiently running 110, 120 degree water throughout the house. So this is you're gonna have to pair a project like this if you have a traditional boiler with probably a change in the distribution and some weatherization on the home. I'm going to talk about that more in a little more detail here in just a sec. So these are definitely whole house systems, right? So the cost is such that you're not necessarily going to be going for just a simple partial fuel switch. This is a whole house system. I'll note that there's a potential for domestic hot water to be tied into these systems. If you have specific design questions, definitely reach out to us. You may be able to use existing distribution infrastructure. Okay, so I was getting a little ahead of myself on the last slide. This is where I want to talk about this. If you have distribution that's already sized for lower temperatures or designed for lower temperatures, these can be plug and play, which is awesome, right? If you already have a radiant slab with a few different zones, right? Maybe not just one big giant zone, but if you have a zoned radiant slab, these air to water heat pumps are an awesome opportunity. In terms of traditional radiators, if you have cast iron radiators or fin tube radiators, and like I said, if you want to have conversations about sort of specifics, you're welcome to reach out. Those are designed for boiler temperatures, right? 180 degree water. If you have panel radiators, some people call them European radiators. I'm going to jump back and show you. That's the one on the top right here. These are sized for lower temperature distribution. They have more surface area. They're just more efficient as temperature distributors. So for an air to water heat pump, that's the kind of, if you don't have radiant slabs, that's the kind of radiator that you may need. I know I'm throwing kind of a lot of details at you here, but that's something to keep in mind. You really want to have that low temperature distribution. If you don't, these are not going to be plug and play, right? So most boilers in the state, people have fin tube radiators, and those aren't going to be plug and play. However, if someone is really interested in going to an air to water heat pump, I have colleagues internally who have done that work. They pulled out the existing system, distribution system, and put in those European radiators, those panel radiators, and they're very happy with it. This is a Cadillac system, right? This is really nice, really good distribution, really comfortable. But installing and replacing hydronic distribution is time consuming and expensive. There's no sort of ifs, ands, or buts about it. That's how it's going to be. I'll also note that while you can tie in your domestic hot water, you can't really tie in cooling without a little bit of extra work. It's difficult. I shouldn't say it can be done, but it's difficult to do cooling through any kind of radiators. And so you can call if you want to talk about specific products, but there are products out there that allow you to run a little fan coil that allows you to cool with an air to water heat pump. So it's not impossible, but it adds a little bit of infrastructure and expense that's required to do that. Where do these work well? I've kind of touched on that a little bit, but if you already have low temperature emitters, such as radiant flooring or those panel radiators, these are going to be really effective for you. This photo on the right shows that, there's a variety of different ways of doing radiant flooring. You can do poured rubber flooring. You can do a poured slab. There's a variety of different ways. But work with a professional, right? There are contractors out there who know how to do this work really well, know how to zone the system, know how to distribute the system well. So if you're going for this is a high level of design, a high level of work with a specialized contractor. You have to get the appropriately zoned distribution, right? So I mentioned that earlier. I sometimes can overlook that when I say to people, hey, radiant slab means you're a plug and play opportunity for an air to water heat pump. Technically, you also need some appropriate zoning. Again, this is something that you can reach out to us for a one-on-one call. You can have your folks in your community reach out to us for a one-on-one call, or you can have them reach out to a contractor and if this is see if this is the right fit for them. And I'll tag that these can be included in more extensive retrofits, right? So if you're doing a gut rehab on the house and you're changing a lot of details, that's a great opportunity to do something like this in an existing home. Just because the level of infrastructure change can be pretty considerable.
Hey, Nate, we have a few questions about air to water heat pumps that I thought I could pose really quickly if that's fine.
Sure.
Great. Okay, so Heather asks, is it possible to use an air to water heat pump or a heat pump hot water heater to preheat the water for an oil boiler?
Yeah, that's a good question. I mean, an air to water heat pump can be tied into another hydronic system. They could probably serve the same tank. I think that's a little bit of a custom design, but you could absolutely work with a designer to do a system like that. A heat pump water heater, that seems less likely. The heat pump water heater, just to recap those real quick, they're pulling heat from the space that they're in, right? And they're so efficient that we don't lose a lot of energy by virtue of them doing that. But it would be difficult to use one of those to then preheat the water that's then going into the boiler. I don't think that would necessarily be an efficient use of a heat pump water heater, but an air to water heat pump can be tied in. Let me try not to make anybody seasick, so I won't go flying back. But over on the bottom right here, you can see that you can do some pretty advanced and technical distribution systems where you tie a couple of systems together.
Great. And the second question we have is from Spence. He says, radiant heat, I think heat avoids drafts. Is there a way to mitigate drafts from, I think he meant a wall-mounted ductless heat pump? Yeah,
that is a good question. Sorry, people, if I'm looking off to the side, I have the chat pulled up over here, and now I'm kind of reading alongside back and stuff. I'm not looking at my camera. It's true that any kind of hot air system, you could feel those drafts, right? If you wanted to think about specific products that can help cut down on those drafts, those ceiling cassettes sometimes work well for that. I think ultimately, if you are sensitive to that moving air, which that's one of the principles of HVAC design, right? We think about our comfort in terms of dry bulb temperature exclusively, but that's not the only thing that matters to us, right? It really matters how warm our surfaces are around us. It matters if there's a differential on either side of us, and moving air really impacts how we experience heat. So if you're quite sensitive to that, a radiant system is probably the best system for you. In most cases, this can come up for people, right? With ductless heat pumps, that air doesn't feel super hot unless you're right up next to it. So that's something to keep in mind. This goes back to kind of some of the foundation I laid earlier. What are your comfort needs? If you don't like the feeling of air blowing, either work with a contractor and try to think about, okay, where do I normally sit? Am I going to be getting blasted at my favorite chair for watching TV or reading a book if I put my heat pump here? So that's something to keep in mind. But if it's a real concern for you, yeah, definitely a radiant system is going to be a better bet.
Great. Thanks, Nate. You can keep going.
Okay, thanks, Becca. Thanks for highlighting those at the end of the air to water heat pumps section. Again, try not to give anybody any seasickness. and jump over to ground source heat pumps. So ground source heat pumps get a lot of buzz because they are really high efficiency systems. And we talked about why that is. But as I said, we're really climbing the complexity and cost ladder here. So they are, I'll just start by saying this, they are in most cases the most efficient systems, and in most cases the most expensive systems. So there's definitely a trade-off there. So let's talk about why that is. A lot of people will call these geothermal heat pumps. I prefer the term ground source heat pump. Technically, we're not tapping into geothermal heat in the way that like Iceland does. We are using the ground as a thermal battery, right? So we take advantage of the stable temperature below the first 4 or 5 feet of the earth, right? So regardless of the time of year, once you get a few feet down, it's pretty much always like 50 to 60 degrees, 50, 55 degrees below grade. And so by drilling wells and putting typically like mostly water, but a little bit of refrigerant mix in those wells, we're able to take advantage through conductivity of that temperature downstairs or downstairs below the ground. And that is a really efficient and effective thermal battery. These systems include a lot of pieces. That's what the little diagram down on the bottom shows. There's your outdoor infrastructure, which is going to be either a well field or some vertical wells. Typically, it's going to be vertical wells. A water pump for pumping that liquid through the wells underground. The heat pump unit itself, and whatever your indoor distribution infrastructure is. I want to tag that one of the helpful things about these is that they can be designed to work with either a forced air system, like a furnace or a ducted heat pump, or hydronic distribution, like an air-to-water heat pump or a boiler. But again, we're designing here for low temperature, right? So same rules apply. Your ductwork has to be designed and sized appropriately. Your distribution system has to be designed and sized appropriately for low temperature distribution. So just because these systems are technically more efficient doesn't mean that they overcome that sort of distribution efficiency question. Some of the details here. So these can operate at super high efficiencies, right? COPs of 5+. Coefficient of performance, put $1 in the acronym jar. Coefficient of performance can be really high on these. That's a sort of a comparison to traditional heating systems. These can provide really consistent temperatures all year, right? The temperature below the ground is stable. So in the middle of the winter, when an air source heat pump might start to lose some efficiency, and in some cases lose some capacity, this isn't going to happen for a ground source heat pump. Same thing in the summer at the really high temperatures. It's really consistent for your cooling all year round. And if you already have a radiant slab, or the right ductwork, but here it tends to be more likely that you already have the right hot water system. This can be possible. It's possible to retrofit one of these into an existing heating system. On sort of the cons side, number one thing I'll highlight is these tend to be the most expensive whole house options. They have at least the same level of infrastructure complexity on the interior as an air source heat, or excuse me, an air to water heat pump or a ducted heat pump. And there's also well drilling, right? So you have to bring a crew in who can drill a well, run those refrigerant lines underground. So that is not only expensive, it also has certain requirements. You have to have the right drilling or site-specific conditions. And there's a whole sort of added layer of complexity and design that goes into that. So these are, in a lot of ways, a lot of people look at these as sort of the perfect system. I don't personally see them as the perfect system. I see them as the most efficient system, but there are a lot of trade-offs. So in the end, going back to that first group, the ductless heat pumps that we looked at, those are going to be super flexible, easy to put in a lot of cases. But if your comfort needs and your budget allow for a ground source heat pump, great. These are going to be super efficient and you're almost guaranteed to be super happy with it in the long run. Where do these work well? I don't know actually that much about this house, but I can tell you that it's big and probably really complicated. So for larger homes that need a significant heating retrofit, again, if your comfort needs require it and your budget allows for it, and you want to make a significant change to whatever your system is, these can be a really effective system for complicated homes where you're trying to get at a lot of different parts of the home. You need to have the appropriate site conditions for drilling or excavation. And of course, you need lower temperature rate distribution. I think ground source heat pumps, if you're going for one of these, you are expecting it to be really efficient and really effective and really comfortable. So it's worth putting in the time and the design. There aren't a ton of contractors on the state who do heat pump or ground source heat pump work and design, but the ones who do tend to be very effective and knowledgeable. So it's worth working with a professional who knows what they're talking about, knows what they're doing, for a system of this scale and this size. Kind of a quick summary breakdown of those three. Like I said, we were working up the scale as we worked through those 4 different heat pump types. Ductless heat pumps, they're going to be decentralized, so that's going to change how you experience the heat, right? It's going to change how you use them alongside your existing system. There's no distribution, but they're the least complex and the least expensive to install, so they end up being very deployable for people who are looking for partial fuel switching, a little bit of air conditioning, variety of things like that. Ducted heat pumps, again, a bit more complicated, but you're getting that ducted distribution. Air to water, if radiant is right for you, this is a really good opportunity. If you already have a radiant slab, this is also a super good opportunity that's going to bring down that install cost quite a bit on the air to water heat pump. And then ground source heat pumps, obviously, there's the well drilling involved, so it's quite complicated, pretty expensive, but the efficiency gains are pretty massive. So if it's in your budget and works for your home, it can be a super effective and really solid choice. I'm going to zip through here. I'm kind of a little over, about 2 minutes over on where I was shooting for, so I'm going to move a little fast here. But just to tag for you guys where to get started, if you have questions about your own home, or you want to send people resources, or send people toward our resources in your communities, if they have questions and you want to get them set up with us at Efficiency Vermont, you can contact our customer support. We have these great services called virtual home energy visits, where myself and my colleagues will talk to you on the phone for 90 minutes about your home, about your goals, about your comfort needs, about your budget, try to think about what the exact right opportunity is for you. So you don't just have to go off this PowerPoint. We can actually have a conversation about your specific home. Definitely look out for Efficiency Excellence Network contractors, and learn more about our rebates. And some of our utility partners also have rebates, so check our website, check their resources online. Those are all good places to kind of get started to figure out exactly what the right opportunity is for you. Once you're sort of rolling down that process, you're going to want to start having conversations with us, with the contractor, figure out the right heat pump for you. Just kind of giving you guys a breakdown of the process here, so there's no surprises along the way. Heat pumps do come as a point of sale rebate. So if people in your community or you yourself look at it and say, hey, I thought there was an Efficiency Vermont rebate, that's a point of sale rebate. So that is applied when you purchase the unit. The unit will get installed. Your utility may have some additional post-install rebates available. So just want to call that out. That's something to communicate to your community members. They may not know that, may want to know that. And then, of course, there are also federal income tax credits. There's more stuff. There's quite a bit of stuff coming from the federal government right now. So that's something to keep in mind and do some research into as well. And my last slide here, I want to flag that there are some financing options as well. So if that is something that you're interested in, especially if you're doing some of these larger, more central projects that I talked about today, we have some great opportunities. Home energy loan and the weatherization repayment assistance program. These are both good financing options that you can really work on getting to that decarbonized and more comfortable and less expensive house that you're looking for. Definitely look for our rebates and look for our financing options, because they're really good opportunities for most Vermonters around the state. Okay, I flew through a lot of stuff. So I have some time for some questions. I want to give some time to my colleague, Matt, to walk through some of his slides, some of the resources that he is going to be able to provide for you guys. So might not spend a ton of time on questions here, but let's walk through a couple. Becca, I know you've been monitoring the chat, and let's see what you got.
I think we can probably get through most of them in the next few minutes, but if not, maybe Nate, you could put some answers in the chat. Steve asks, is there a generic table for COP, or does COP vary by manufacturer? Where could they find that table?
Yeah, that's a good question. I mean, it can vary a little by manufacturer. So COP is going to be manufacturer dependent, condition dependent. So, I didn't say this outright. I should have cold climate heat pumps. You want to look for cold climate heat pumps, right? There are heat pumps that are not designed for the cold. They're going to have lower COPs at lower temperatures. So there's a resource from the Northeast Energy Efficiency Partnership that has, again, sorry, I'm looking off camera. I'm just reading your question, Steve, as I talk. But there's the NEEP, Northeast Energy Efficiency Partnership. They have some really good resources online where they consolidate a lot of information about heat pumps, and you can look at their performance. You can also look at manufacturer performance data. That's another thing you can reach out to us about too, if you want to have a conversation about one unit versus another.
Great. And it looks like Keith actually put that information in the chat. So that's great.
Way to go, Keith. Thank you.
Yeah. Another question from Steve asks, what happens when the temperature is below -20 degrees? I assume that the efficiency is dramatically lower, but does a mini split still deliver useful heat?
It's a good question, Steve, and it's going to depend on a variety of different things. I mean, it depends on the manufacturer. So when you're getting to -20 Fahrenheit, there are some heat pump manufacturers who are starting to rate their equipment that low. I think typically Mitsubishi's are rated down to -17, but will continue to put out useful heat after that. How you experience that heat is going to depend a little bit on the design and a little bit on your own home's thermal shell. The efficiency is going to go lower. It tends to get closer and closer to the efficiency of electric resistance heat at that point. But if you are choosing high quality cold climate heat pumps, they should still continue to put out heat all the way down to temperatures that low.
Fantastic. Another question from Spence. Can a ground source heat pump designed only for heating be retrofitted for cooling?
Yeah, absolutely. So, I mean, if it is a heat pump, it's capable of both. The question would be your distribution system. So if you have a radiant distribution system, you would need to add some kind of fan coil and ductwork to add cooling. If it's already designed with ductwork, it should be pretty straightforward to switch that over into cooling mode. So that's definitely a possibility.
Great. Okay, two more, and then I think, or one more, and then we'll maybe answer some in the chat, or Matt can maybe take some on. But Heather asks, is there a better or worse location for the outdoor unit from an air-to-air heat pump, for example? Do they do better on the south side when they may benefit from a bit of solar gain to surrounding air temperatures?
Yeah, that's a good question. I think it's a little bit situation dependent, though, on sort of a really simple level. Yes, hiding them in the shadow on the north side of your house can probably, they're going to be in colder air, so that's going to make them run at lower efficiency more of the time. It's ultimately a conversation to have with a contractor, because some of the more considerable constraints will be where to run the refrigerant lines in the house. Feel free to reach out if you have some specific questions, Heather, or yeah, that's a really good conversation to have with a contractor and say, like, hey, you're saying it should be over here. Is there a reason it should be over there? Often it's going to depend on where the inside unit is and where they're going to want to run those refrigerant lines and the drain and some of the things that are some of those practical constraints, I should say.
Great. Okay, I think we should turn it over to Matthew to present the last few slides, and then maybe Nate, if you could answer some of the chat, or we can get to them at the end. But I definitely want to make sure Matthew has enough time. So
yeah, thanks. Nate, that was great. Thank you so much. I've watched you give that presentation before, and I've heard it before, and I still feel like I'm taking new things away from it. So appreciate that expertise. And Nate, I will be calling on you to move on to the next slides. So bear with me. Folks, hi, my name is Matthew Smith. I'm the Public Relations Manager here at Efficiency Vermont. Just want to call out, I see those questions about the IRA, the Inflation Reduction Act, in the chat, and I'll get to those in just a second. But I'm here at EVT, Efficiency Vermont, because, like you, I think it's really important that we spread the word about ways we can all kind of chip in and solve the climate crisis. And a really great way to do that is to talk about heat pumps as an affordable solution that are real for Vermonters. You know, as Nate just said, these are really effective, and the newest versions of these systems are really helpful to even in the cold that we experience here in Vermont. So I want to talk to you now about a solution to kind of take what you've heard here today with you and how you can engage people in your community, your town government, your town energy committees to help spread the word and share with your neighbors the information that you heard here today. So first, I don't want to leave any folks hanging. I'll just kind of answer those IRA questions before I kind of dive into some more of this. And Nate, if you wouldn't mind moving on to the next slide, please. Should at the top say spreading the word, maybe just one more if you would, Nate, thanks. So those IRA questions, you're absolutely right. Some really landmark legislation coming out of DC, the Inflation Reduction Act, that's coming to all the states. And the way that works is each state is allotted a certain amount of money, and a designated agency in that state determines what programs and how that money will be spent. About $58 million, I think 58.6 to be exact, is coming to Vermont through the IRA. How that money will be spent is currently with the Department of Public Service. They have to lay out their plans, how it will be spent. The HERA and other funding programs for low-income and moderate-income Vermonters. All of that has to be then filed with federal Department of Energy regulators and approved. And only then will we really be able to start implementing these programs in the state of Vermont. So unfortunately, while there's a lot of cool stuff happening, just how that money will be spent and when it's accessible to Vermonters is in the hands of the Public Service Department. We're hoping sometime in the first half of 2024 that information will be shared. So turning back to some strategies for spreading the word. First, I just want to share, encourage you folks to tell someone here today or someone who wasn't on this call today, tell them about some of the stuff you learned about heat pumps today. Share a link to the slides that will be coming when we finish up here. Just get that conversation started. You know, not everybody is as perhaps interested or excited to know about heat pumps as you. Some folks might be interested, but they don't quite know where to begin. Maybe your town energy committee has these priorities on the radar, but a lot of people need a way in. So a conversation with a trusted member of the community can be just that. And you all have some great heat pump info in your brains now, thanks to Nate. So tell someone about this webinar. Tell folks about the work going on at VECAN. Explain to them about heat pump technology, whether it's in your home or stuff you've learned from this webinar. And, you know, it's really important to get those conversations going now because, you know, more options, more affordable options will become available. But when people make those decisions about what kind of new heating system they need, it's often something that they make when their old one fails. So the more information you can kind of get out there and have in people's minds before they reach that crisis point, they'll be better equipped to consider a heat pump and consider a solution that both meets their heating needs, but also helps them save money and cut some emissions. Next, I just want to encourage you to meet your community where they already are. If you're on a town energy committee, use the venues and opportunities that your town already has. Consider tabling at community events that you know are well attended. Ask food shelves, for example, if their patrons need information about weatherizing a home, buttoning up their home, adding some insulation, using some of the great do-it-yourself rebates Efficiency Vermont has to make your home a little warmer. And that might be the way in to get people to start thinking about weatherizing their whole home, shifting to a more efficient heating system, things like that. So really take advantage of the platforms your community already has to kind of get the word out. Third, you know, as I mentioned, not this kind of information about heat pumps isn't necessarily top of mind. I applaud everybody here for being willing to sign up for a heat pump presentation on a weekday afternoon. But, you know, for a lot of people, hitting them in the wallet is more effective than hitting them in their conscience, whether it's saving the planet, saving money on their bill might be a more effective way to activate their interest in heat pumps and more efficient technologies. So, so like I said, get that conversation started, going with folks, and just keep in mind for a lot of folks, they're concerned about costs. They're concerned about comfort, if that system will provide the heat that they need for their home and their family. They're concerned about control. Does that system give them the heat they need when they need it? And, you know, it's different for everybody, but only then perhaps some people are thinking about the climate. So just recognize people are coming from different starting points in these conversations. One final approach here is that, you know, energy efficient technologies, they compete with some basic needs. A lot of people just want a refrigerator that works. They just want a heating system that just works. So, you know, there's a lot of different stages on your efficiency journey, and the information you take from this webinar today, and the idea that, oh, maybe get that house weatherized before you take that big step on a new heating system. That's a great first step to get people thinking about energy and efficiency in their lives. And eventually they might kind of catch up to you on figuring out what heat pump system is right for them. Nate, if you wouldn't mind, next slide, please. Thank you, Nate. I know I'm running short on time here, folks, so I just want to share a few resources. You know, we are here at Efficiency Vermont, but there's a lot of resources out there online. This first link goes to kind of folks who do similar work in Maine, Efficiency Maine. It's a tool that can let you put in a couple of different inputs about your heating system and costs, and kind of get a very rough estimate. And I emphasize rough estimate on what it might look like if you were to switch your heating system to a heat pump. You can plug in your current system and rates and see what that costs, plug in a heating system and your electric rates to figure out what that is. Now, just again, keep in mind, this is a useful tool for estimating, but your actual costs will differ depending on, well, how insulated your home is, the performance of your current system. So really just, this is a very rough estimate. And to get a more specific estimate, a home heating professional would be able to give you an accurate sense of what your actual costs would be with a new system. Another great resource there, this kind of would work, I think, for the folks who are curious about the IRA, the Inflation Reduction Act stuff. Rewiring America is a great nonprofit that really try and educate the public about electrifying your home heating system and your community. So this link here can kind of let you punch in your income and your location and get a sense of what might be possible for you as the IRA dollars start coming to different states. As I mentioned, those decisions are with Vermont's Public Service Department right now, but it is a useful tool, this website. And just so you're not thrown, a lot of this information is already on Efficiency Vermont's website. And I threw here an example of our heat pump rebate. You can see right there, in addition to the rebate that Nate talked about, that midstream rebate, if you scroll down a bit on the website, there's very specific information about what your utility might offer for rebates and some federal tax stuff as well. So a lot of those rebates that you might kind of see on that Rewiring America tool, they're on our website as well, the Efficiency Vermont website. So just some useful tools outside of Efficiency Vermont for you folks. And Nate, if you wouldn't mind clicking over to the next slide, please. Thank you, Nate. So as I mentioned, we're Efficiency Vermont. We've got a lot of great tools for you as well. I want to just point you to a few. And again, keeping in mind how you can take this information with you, how you can kind of get it portable and shareable with folks in your community. That first link on this slide here, our partner resources page has a lot of resources you can print out on a computer at home, great flyers to post up somewhere in your community, or even just share with somebody who might be thinking about a heat pump or is a renter and wants to know what kind of efficiency steps they can take. That partner resources page is a great place for those kinds of flyers and handouts. They can be specific technologies like heat pumps. They can also be financing options, like how you can take advantage of a zero interest loan for a home energy project. Our website in general, as I mentioned, a lot of great how-to guides, blogs that have customer stories from real Vermonters about installing a heat pump and how they chose what they chose for their system. And the website, of course, has the most up-to-date information on our rebates, discounts, programs like that. So you've heard Nate say this as well, getting started on your efficiency journey is really a crucial first step, and that is easy and free to do through Efficiency Vermont's home energy assessments or virtual home energy visits. So you can start that process with a phone consultation. That phone number is on our website. Probably should have put it right here on this slide, so forgive me. And you can also schedule a free virtual home energy visit, and that really gives you the specific information you need. And I've seen Nate kind of do those sitting next to me here at the Efficiency Vermont offices, and he's really thorough. So those are really helpful to understand what you might need in your home. Just a few more notes here about what our website offers. That Find a Pro tool can help you find a contractor that specializes in the technology you're looking for. So for example, if you're looking for an installer for a heat pump, as Nate mentioned, those ground source heat pumps are really complex and they need a very knowledgeable professional. That Find a Pro tool can help you find the professional you're looking for. We have a retail marketplace. You can compare different Energy Star labeled products, appliances like refrigerators, air purifiers, things like that. And we have a constant stream of new events, trainings and educational opportunities. So really, just want to emphasize that website can be a great resource for new and upcoming, but also a repository of some great information. Thank you, Becca, for posting the phone number there. I'm kind of running a little short on time, so I'm going to skip my last slide, which is just more information about Efficiency Vermont. So just trying to give a quick broad overview of all the different stuff we do. And Nate, I'll just ask, click over to the last slide and leave any time we have remaining for some questions.
I don't think we have a ton of time, but if there is any questions we didn't get to, I think we can follow up. There's a few folks maybe, and then maybe I'll just turn it over to Dan to say any final things about upcoming webinars.
Thanks so much. Thank you all for coming today, and thanks so much to Nate and Matthew, Becca, and Michelle. Amazing team at Efficiency Vermont. It's a really good presentation and so important. And you all are answering so many good questions in the chat and here. So if you have questions, definitely reach out to Efficiency Vermont. They have the answers. And they know the contractors who have the answers. So please do that. We are doing this webinar series every 2 weeks. And so our next webinar is February 14th. The Vermont Energy Education Program is talking about community workshops and ways that we can get more community education, which is what Matthew was just talking about. So hopefully you all join us for that. And with that, I'm just going to say thank you all and have a great day.